the charges do touch, that there's a transfer of electrons. That's why you shock. All right. So it says there, if we have, where's your notes? Okay, that is not working for me at all. Kumo, please move all the way to the corner, and then the two of you just move up, please. I can't, the two of them, I'm going to throw them with something. All right. Transfer of electrons. So when they say when you have two objects with unlike charges. Now, I already said unlike can mean negative and positive, but it doesn't have to mean negative or positive. It can also mean neutral and positive, or neutral and negative, or very negative and a little negative. Okay, so it doesn't have to be positive and negative. All right, now, your job is to keep him focused. So if he's not focusing, you slap on his desk. Ole, same goes with you. Right, so did you make a note where I wrote down that? Because I know it. Then don't pee. Open your nose. Okay. So when they touch, or when they're brought close to one another, then there is a transfer of negative electrons. So electrons are transferred. Until when? When does it stop transferring? Until the charges on both objects are equal. So it doesn't say until they are zero or until they are neutral. No. Until they are equal to one another. Okay, so let's see quickly the example here. Here we have two charges or two spheres. Now, before they touch, we're going to assume they're not touching there just yet. Before they touch, the first charge has how many protons? Did I start somewhere? Yes. Kutlano, how many protons does it have? The first sphere. Say again? 6 protons, and how many electrons? 4. So if you add them together, what is the net charge on that object, Siyabonga? What is the net charge? It's 2 what? 2 positive or 2 negative? 2 positive. So this one, sorry, not 4. It is 2 positive, the net charge. Right? If you look at the next one, Rory-san, how many protons? 6. And how many electrons? 0. So what is the net charge, Zara? Okay. So 6 protons. So you can see that they are not the same. They're not similar. They're unlike. Not opposite, just not the same. This one is 2 positive. This one is 6 positive. Alright, now they touch. Now there will be a shock. There will be a transfer of electrons. Courtney, from where to where will the transfer of electrons be?
From the second one to the first one.
What can be transferred? Protons or electrons? Okay, so protons cannot be transferred. They stay where they are. Electrons can be transferred. So say again.
The first one is going to transfer to the second.
And how many? 2. Because they both have 6 protons. And this one has 4 electrons and this one has none. So it's going to transfer here 2 electrons when they touch. So that when we look at them when they are separate again, this one has 6 protons, 6 protons. If it transferred 2 electrons, then this one is left over with 2 electrons, and this one is left over with 2 electrons. All right, so this one still has 6 protons and 6 protons. This one now has 2 electrons and this one has 2 electrons. So, Relo, what is the net charge on the first one? So 6 protons and 2 electrons. What is the net charge on the first one? 6 positive, 2 negative. When you add them together, what do you get? You owe me 6 rand. You owe me 6 rand. You give me 2 rand. How much do you still owe me? 4 rand. So we have 6 plus negative 2. So it means plus 4. So we have a 4 plus and a 4 plus. So you can see when they touch, there will be a transfer of electrons until they are equal to one another. Alright, now that concept which we looked at just now is called the law of conservation of charge. Alright, now Rita Bila, can you please tell me what does the word conservation mean? Okay, I'll give you an example. The conservation of rhinos are a high priority in South Africa. Is a high priority. You know what is a rhino? And what is the big talk regarding rhinos in South Africa? What's happening to the rhinos? Why are they endangered? And what does the poachers do? Why? Why? But why do people want the horns of rhinos? No, but someone buys it. Why does that someone buy it?
Medicine.
Huh?
Medicine.
Yes, medicine, that's not the top priority. That's not the top priority. It's not South Africans that pay a lot of money for the rhino. It's the Chinese. It's not African medicine. What do the Chinese do with it?
The rhino one says what you call no. It has the thing, which is very good.
They grind it, and I think if you consume it, you become no, you become something that Kumo wants to practice. They become charged. Alright. It's for their sexual pleasures. Alright. But it's just a myth, it doesn't happen.
It does.
How do you know? Careful what you say. Alright. So people buy it, people poach it, blah 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 blah, don't do it, you kill the rhinos. Okay? So when I say the word conservation, the conservation of rhinos is very important. What do I mean by that? Protecting it, keeping it close, keeping it together. Okay, so when we say the law of conservation of charge, we mean that the charge must be the same. The charge mustn't change. Okay, that the charge that we have at the beginning must be the charge that we have at the end. Okay, so that is what we did here at the top. We saw, right, we had 12 protons and 4 electrons. At the end we have 12 protons and 4 electrons. We didn't lose electrons and we didn't gain them. Okay, so the total charge at the beginning is equal to the total charge at the end. Alright, so that is what the law of conservation of charge means. Let's read it. It says the net charge, and that net word is something that I used here. I asked, what is the net charge? That was the net charge. When you add and subtract, what is left over? The net charge of an isolated system. Chloni, what is isolated system? When I moved Kumo, I wanted to isolate him from Bukamuso. keep them away, keep it closed. Alright? So an isolated system is a system that has no impact from outside. Okay, so in your head you can think a closed system. Okay, so an isolated system is a closed system. Okay, so what remains constant? The net charge remains constant during any physical processes. Touching, rubbing, blah, 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 blah. Say again?
Physical touch.
Yes. Alright, so that example is not part of the definition. Remember, anything in a block is a definition. So two charges making contact and then separating. Okay, so at the bottom I said it in another word, so that is not part of the definition. It says the sum. What is sum again? Plus. The sum of the charges at the beginning is equal to the sum of the charges at the end. All right. So when we have two charges that are not the same and they touch one another, then there will be a transfer of electrons until they are equal. To get this new charge, we have an equation, and there is the equation. New charge, we have an equation. So what we do is we add the two charges together, and then we divide by the number of objects. So if we have 3 objects, we divide by 3. If we have 2, 2. 7, 7. Okay, let's look at a question like that. It says 2 metal balls of equal size carry charges of that and that respectively. They are brought into contact and then separated. Carabello, please tell me what happens when charges touch. Say again?
When charges touch,
Yes.
they transfer
What transfers?
the electrons
Okay, until?
until they are equally
Yeah, until they are equally charged. Ne? Alright. So, what is the new charge on each ball after they have touched? Okay. So, when we calculate the charge, this is the charge of the first one. Plus, remember, the thing says the sum of the charges. So, it's a plus. Divided by, we have 1, 2 charges. So, we're going to divide by 2. If there was 3, we would have divided by 3. Okay, so that is 2 times 10 to the power negative 11 plus negative 8 times 10 to the power negative 11 over 2. And the renewal is on it, but you don't trust her. I wonder if you can do it in your head. Now let's ask Ntando to do it in his head. Ntando, quickly put on your calculator. Okay, and then Renewal will tell us if you're right. 2 plus negative 8 gives you what? Divided by 2. So we have negative 3, and then what is left over? Times 10 to the power negative 11. Is that right, Renewal? It's not the calculator, it's the person typing in.
she's scared, man.
What? Then you're going to say 2, and then there's a times 10 to the power button there at the bottom. Use that. Yes, times 10 to the power of, and then we have negative, and negative, you use that negative button there at the top. Negative 11 plus negative 8 times 10 to the power negative 11 over 2.
Luz.
It's infrared.
Luz. Entendi. Ah, agora mais.
Alright. What is the unit renewal? What's the unit? Coulomb. Alright. Then on the next page, and we have touched on this in the previous lesson, when you have two charges, there is a force between them, and the symbol for force is a capital F for force. Alright, so electrical charges exert a force on one another. They will either repel each other or they will attract one another. Okay, so like charges or similar charges will repel each other, and opposite charges will attract each other. Siyabonga, quickly take this piece and just throw it in one of the plants. No, I think you'll be fine. Okay, I'm saving water now. Don't fall while you go down the stairs. Don't throw it from the top of the building. Right. Okay, then the next concept there is polarization. Polarization. Okay. So the definition there, it says the partial or complete polar separation of positive and negative electric charge in a system. Okay, and that is what I showed yesterday with the balloon and the wall. The balloon was very negatively charged. It came close to the wall and it pushed the electrons away in the wall. And it became polarized. You remember that? Yes? Okay, so this is what I show here. So right, let's say we have two uncharged balls here, polystyrene balls. You bring a ruler closer, closer, closer. Then why will it attract the balls? Because inside we have, let's say for each one we have two protons. Proton, electron, proton, electron. All right. When it is brought closer, the protons remain where they are. The electrons will move to the side. They will come closer. Are you drawing this in? They will be attracted. They will be drawn closer. So this becomes polarized because we have a positive and a negative pole. We have a positive and the electrons move closer, negative pole. So they become polarized. Okay. When they touch, the electrons jump from the balls onto the rod. So now it loses the electrons. The balls become positive charge, and what will happen? They will repel each other. Okay, so this is a whole story that we can use.
This one, when you chemically